This is part 4 of section 1.4. We're now going to talk about piecewise functions. These are functions that are literally defined in pieces. They'll use different formulas for different parts of the domain. And it will look something like this, and you can have several of these, not just two. But to be a piecewise function, there need to be at least two parts. When we are graphing these or evaluating these, we really want to pay attention to the domain of each part. So when we go to plug in an x value, we are going to have to look here to first determine which of the two lines we should be plugging into. Now, when you come to a piecewise function, the point where we choose to go from one formula to another, the point where it changes, these are called transition points. So right here, 1 is the point where it goes from one line to the other. So x equal to 1 would be a transition point. Okay, so first of all, let's go with this, where we have g of x defined as 2x plus 4 if our x value is greater than 1. And it is x plus 2 if our x value is less than or equal to 1. So let's find g of negative 3. So I want to plug in negative 3 for x. If my x value is negative 3, is negative 3 larger than 1? No. Negative 3 is less than or equal to 1. So this is the formula I need to plug into. So that will be negative 3 plus 2, which is negative 1. Now let's find g of 1. Is 1 greater than 1? No. 1 is less than or equal to 1, so it fits inside this domain. So I plug into here to get 1 plus 2, which is 3. And then finally, if I plug in 3, 3 is greater than 1. It is not less than or equal to 1. So for 3, I would plug into this line. So I got 2 times 3 plus 4, which is 6 plus 4, which is 10. Okay, so now we want to talk about how to graph these things. So what we're going to do is we're going to graph each of these two lines and then limit them to these particular domains. Now I'm going to start off with this one just because it is probably the most basic one. If I want to graph this line, I'm actually graphing y is equal to x plus 2, which will be the line with slope of 1, and our y-intercept would be 2. Okay? Now what I'm about to do is I'm going to put some random points on my, not random points, I'm just going to put some points on my graph so that I can get the line correct. I'm doing it in a different color on this, on your notes here, but if I were doing it on paper, I would probably use a pencil, just because the points I use may or may not be actually part of the graph. Okay? So if my y-intercept is 2, which is right there, and my slope is 1, so that's up 1 over 1, up 1 over 1, and so on. Okay? So this line is going to look like this. Now what I do want to do is I want to make sure that I get the domain of this correct. So what part am I interested in for this? Only when my x value is less than or equal to 1. My x value is equal to 1 at this point on my graph. And this point is included because I have an equal to. So if I am graphing this line of this part of this in this domain, I have a solid point right here, and then my graph looks like this. And it stops right there. I put this point on my graph just as sort of a guideline, but it's not technically part of my answer. It's just there to help me get a graph. Okay, so now let's do this part. Basically, what I'm trying to graph is y is equal to 2x plus 4. And in this case, my slope is 2, and my y-intercept will be 4. Again, I'm just going to put some guide points on here to help me get the basic shape of the line that I'm trying to graph, and then I'll take care of the domain as I actually draw it in. If my y-intercept is 4, that's right here. My slope is 2, so rise of 2, run of 1, rise 2, 1, and so on. Okay, so the basic shape of that second part is going to look like this. Now I just need to make sure I get the domain part so that I am graphing the correct part of it. Here I want my x value to be greater than 1. I'm not allowed to equal 1. So where this thing starts, since I'm not allowed to equal, I'm going to use an open circle instead of a closed-in circle like I did right here. And it has everything to do with whether or not there's an equal to on it. So when my x value is 1, my graph is right here. I use an open circle. And I'm looking for greater than. So I'm not going to be graphing this part of it. I'm just starting here and then going up like this. So my answer graph has a jump in it. That's an open circle right there, and then the graph continues up like this. Okay? Now let's use this graph to decide the domain and range. Domain is every single possible x value. Okay? Well, this continues out forever this direction. This continues out forever this direction. So the only place I have to think about is where this jump is. So everything, definitely everything, other than this right here is part of my domain. Just check this part. Well, x exists here. It does not exist here, but it does exist at 1. That's just where it jumps. So I am allowed to plug in x equal to 1. So this domain, it exists everywhere. Now the range. This will be every y value where my graph exists. Now as far as the y values go, there is a jump right here. So this area is not going to be part of my range. Remember, range, you're talking about your y values. So you want to decide, first of all, the lowest y value possible. Well, this continues down forever. So it goes down to negative infinity. And then it goes up to 1, 2, 3, y equal to 3. And my y value does equal 3 because it is part of that. It has a closed-in circle, so that's a bracket. And then union, because technically we are combining these two interval notations. My y value here is 6, but it is an open circle, so it is not included, so we use parentheses here. And then my graph goes up to infinity, so this is infinity right here. Okay? Okay, so let's look at this one. This time we're given the graph first, and they want us to give the function representing the piecewise function. So they want us to come up with a piecewise function instead of going the opposite direction. So I think if you look at this, it's fairly easy to see that our two parts are from here to here, and then from here to here. Each of those two parts, each of those two line segments is a linear function. So I want to, if I can come up with an equation for each of these, then I can put that into my piecewise function and then put in the domain and the restrictions that we need. Okay, so what do we need to find this here? If I'm doing this part, well, I need to find, I'm going to use this, the point slope formula, which is y minus y1 is equal to m times x minus x1. And since we have a graph, you can either calculate m by just looking at the graph and figuring rise over run, or you can use the formula y2 minus y1 over x2 minus x1. But for this part right here, our m value, we go up 1 over 3, so that is, our slope is 1/3. Now for your x1 and y1, you can use either of these 2 points. It's just your choice. Personally, I'd rather deal with ones than these numbers, even though these aren't too bad. So plugging in here, y minus y1, which is 1, is equal to our slope times x minus x1, which is 1. Now distribute the 1/3. Now add 1 to both sides, and we get y is equal to 1/3 x plus 2/3. So I have a formula for this part. Now I'm going to do the same thing here. For the second portion, our m value is, to go from here to here, you rise 2, run 2, or rise 1, run 1. Our slope is 1. Now use the same formula, and you can use either of these 2 points for x1, y1, and I'm going with this one just because. So I have y minus 2 is equal to 1 times x minus 4. So y minus 2 is equal to x minus 4. Add 2 to both sides. Y is equal to x minus 2. Okay, so now that we have that, we have the 2 main parts of our piecewise function. So we have 1/3 x plus 2/3, and we have x minus 2. Now we just need to put the conditions on each part. So now basically we are talking about what portions of this we are actually talking about. So from here to here, what's the restriction on our domain? What are our x values? Well, our x values go from 1 to 4. So if 1 is less than or equal to x is less than or equal to 4, and then this part is from here to here, and it goes from 4, I'm going to leave out my sign here for just a second, and this goes to 6. Now this is less than or equal to definitely, okay? Notice this point right here, we do have a point there, and technically it can belong to either of these, okay? So since I put an equal to here, I want to use just a less than here. Okay, but that said, I could have done this instead. These are equivalent and both good answers.